Hello everyone, welcome to LearnNCode. In the previous session, we have completed the topic called bitwise operators in Python. In that session, we have seen various types of bitwise operators like bitwise AND, bitwise OR, bitwise exclusive OR, bitwise NOT, bitwise left shift, and bitwise right shift. In today's session, we are going to start the new topic called assignment operators in Python. Let us see what are the assignment operators or what are the various types in it. So before moving on to the types of assignment operators, let us have some discussion on this. What actually meant by the assignment? General meaning of assignment. See, the general meaning of assignment says that simply we are going to assign some value. This is at right hand side, and this value at right hand side is assigned to the operand or variable that is at left hand side. This is the general meaning of simple assignment. Now, what is another function of this assignment? Not only this simple assignment, the assignment operator can also perform some operations. It can perform some operations. After performing the operations, the result will be assigned as the value to the left hand side operand. This is the advanced version of the assignment statement. So now we are going to talk about the various types of assignment operators. Let us see. The first one we write simply like this. This is simple assignment. We call it as simple assignment. What is the function of this simple assignment? Just it assigns the value at right hand side to the operand which is at left hand side. This is general assignment. Now, second one we are going to talk about plus single is equals to. What does it mean by this? The second assignment operator describes that first it is going to perform the addition, right? After performing the operation addition, the result will be assigned. That means addition and assignment. This is addition and assignment. This is simple assignment. And third one we are talking about minus is equals to. Like addition and assignment, this is subtraction and assignment. Now fourth one, multiplication and assignment. So it is going to perform the operation multiplication first. After that, it is going to assign. And fifth one, we have division is equals to. Now, what is the operation it is going to perform first? Division. After that, the result will be assigned. Division and assign. After completing this five operators, now sixth one we are going to talk about percentage single equals to. That means it is going to perform the operation modulus. After that, the result will be assigned. This is the sixth type of assignment operator. Now, seventh one, we have the floor division. It is going to perform the integer division. After that, the result will be assigned. This is about the seventh one. And the eighth one, we are going to see this. We are going to perform this exponent operation is equals to. Here, we are performing exponent operation. After that, the result will be assigned. And ninth one we are going to talk about is we can also perform the bitwise operations using assignment operator. That is bitwise AND is equals to. So first one represents the bitwise AND. It performs bitwise AND. After that, we are going to assign the value. And next one is OR is equals to. Similar to bitwise AND, we are going to perform bitwise OR. After that, assign. And next one, we can perform exclusive OR operation, bitwise exclusive OR operation, and after performing, we are assigning. And next, bitwise AND, bitwise OR, bitwise exclusive OR. Next, you have bitwise left shift. After performing left shift operation, we are performing assignment. Not only this, and the last one, we can also perform bitwise right shift. It is going to perform bitwise right shift operation, and after that, it is going to assign the result to the left hand side operand. These are the various types of assignment operators in Python. Let us discuss each and everything with an example. Now let us see the first example, that is called simple assignment. Go to the Python shell and you take any variable. I am taking the variable a is equals to 10. Now the value 10 is assigned to a. So here the operation is evaluated from right to left, right? The evaluation is done from the right to left. Now whenever we print a, now we will get the answer 10. This is the simple assignment. Now coming to the second one, take a variable like this. A plus is equals to 10. If I say a plus is equals to 10, the meaning of this is a is equals to a plus 10. This is very, very important. So wherever I write a plus is equals to 10, its meaning is a is equals to a plus 10. See, a equals to a plus 10 in the sense, first you have to provide the value for a, right? Then only that result is added with 10 and the result is stored in the a. Okay, to evaluate this expression, first what we do is, at Python shell, take some value. Just now I said that a equals to 10, right? Here I said a equals to 10. This is a simple assignment. Now in the next line, if I say a plus is equals to 10, the meaning here I said that hash, just comment for I'm using. Just now I said a equals to a plus 10. Now in this case, a equals to a plus 10 in the sense a value how much? Already we have given 10 here, right? Now to this 10, another 10 is added, the result is 20. This 20 is assigned to a. Now if you print a here, the result we are going to obtain is 20. This is the function of plus is equals to operation. So we have to provide the initial value for the a before performing the operation plus equals to. Similarly, third one we are talking about is minus is equals to. At the at the Python shell, you take some variable b is equals to 3, right? After saying here, just I'm writing that b minus is equals to 2. B minus equals to 2. So what is the meaning of this b minus equals to 2? B is equals to b minus 2. This is the meaning of this. That means new value of b equals to, old value is b is 3. 3 minus 2 is equals to 1. Now whenever we try to print the value of b, now we are obtaining the value 1. This is the main purpose of minus is equals to. Similarly, we can use any operation like if I say b star is equals to 2. In this case, b is equals to b into 2. This is the meaning. B equals to b into 2 in the sense already we have provided the value for b is 3. That means 3 into 2, how much? The b value we are going to get is 6. Likewise, you can perform the operation, fifth operation, b division is equals to 2. What is the meaning of b division equals to 2? The meaning of this is whenever we say b by is equals to 2, so you are, that is b is equals to b by 2, right? Just now I said. Or the b value 3, 3 by 2, how much? We are going to get 1.5. So in this case, whenever we try to print the value of b, we will get 1.5. Like this, we can perform other operation like b is equals, b percentage is equals to 2. In this case, the meaning already I said b is equals to b modulus operator 2. And just now we said that b value, old value of b is 3. In this case, new value of b is 3 modulus operator 2. That means we are dividing 3 with 2. So 2 1s are 2, the remainder is 1. The new value of b is 1. So at the at the Python shell, if you say b modulus operator is equals to 2, when you try to print the value of b, now we are going to get the value 1. Similarly, we can perform any bitwise AND operation. For example, if I say at Python shell, b bitwise operator is equals to 2, in the sense just now I said b is equals to b bitwise and 2. Now B value is 3, that is converted into binary, 2 is converted into binary. After that, bitwise operation is completed, and the result is stored in the form of decimal value that is stored in the B, and that is printed B here. So similarly, you can perform operations like bitwise or, okay, next bitwise left to shift, bitwise exclusive or, same thing you can do. Okay, and also you can perform bitwise left to shift. If I say bitwise left to shift is equals to 2, in this case, similar meaning. So B is equals to B left to shift 2. That means B value how much? 3, and left to shift to 2. It is converted into binary, and we are going to shift how many bits? 2 bits. So same thing we have seen in the previous session, right? Finally, the result is assigned to B, and that B is printed here. This is the logic of using the various types of assignment operators. Not only left shift, you can go for the right shift, anything you can perform. So these are the various types of assignment operators, right? So next we are going to talk about the next topic called membership operators in Python. After that, we will see the identity operators in Python. Now we will discuss membership operators in Python. So what do you mean by the membership? In what context we are talking about the membership? Let us take a circle here and assume that this circle we are calling is sequence. Now, what do you mean by the sequence? The sequence may be a list. This can be a list, or it can be a tuple, or it can be a string, or it can be the dictionary. Okay, so in the coming chapters, we are going to discuss what do you mean by the list and tuple strings and also the dictionaries. Just here assume that here we are taking the domain or the sequence where we can have a list or tuple or string or anything, a dictionary also you can take. Now, in the entire sequence, what we are going to do is we are going to check the membership. For example, here I'm taking a member X. Now I'm going to check the availability of X, or I can say existence. I can say existence or availability. What I'm going to do here is I'm going to check the existence or the availability of the value designated by X in the sequence, in a specific sequence. What do you mean by the sequence? It can be a list. Just now I said it can be a tuple, it can be a string, or it can be a dictionary. Now for this, how many types of membership operators are there? The first one we are going to use in operator. In operator, and second one we are going to use is not in operator. What this in operator is going to do? If a specific value X is a member of sequence, or if a value of X is found in the list or in the sequence, the sequence may be a list or anything, within this entire circle of sequence, if X is found, then the operator in is going to return true as the result. Right? If X is not the member, or it is not available, or it is not existed, or it is not available in this particular sequence, then not in operator is going to return the result as true. Simply remember that the membership operator in is exactly opposite to not in. In returns true when the member is not, sorry, in returns true when the member is present or when it is existed in the sequence. Whereas not in returns true when the member is not found in the sequence. This is very, very important. That we will see with example. You do one thing, you take some number, or first you have to take the sequence and also the value. Now let us go to Python shell, right? This is the Python shell. Here I'm going to use a variable s1. S1 is equals to, just in the double quotes, or you can use single quotes to represent the string. S1 is equals to, just I'm writing learn and code. This is the string I have given, right? Now S1 is the string. That means that this is a sequence, specific sequence. Now see here, S1 is learn and code. Now what I'm going to do is I'm going to take another variable x. Okay, x is equals to, we are going to assume n. X equals to n. Now the value of x is n. Now I'm going to search this, whether here I'm writing x in S1. I'm checking x in S1. S1 is learn and code. Now what is x value? N. N is in S1. In this case, it is going to return the result true, right? In case of, if I give x is equals to, if I write in single quotes or double quotes and, now I'm taking x equals to and some simple string and, this is substring I can say. I want to search this x whose value is and in the string S1. Now if I say x in S1, in this case it returns false. In place of in, if I use a Python shell x not in S1, now x is and, right? And is not there in S1. Now in this case, it is going to return the value true. This how the membership operator is going to work. Let us take another example. Let us take the list. Assume that here I'm using the list num is equals to, just now I have used the string as a sequence, right? Here I'm using the list num equals to, for example, I'm giving the numbers 1, 2, 3, 4, 5, 6, 7. These are the numbers I'm giving, right? Now I'm taking some value n is equals to 10. N equals to 10. Now here I'm going to use the membership operator n in num. N in num. Number is the list. Is 10 is there in the list? No. In this case, it returns the result false. If I use, what do you say, n not in number, okay, not in 10 is not there, right? In this case, it returns true. This how the membership operator in and not in are going to work. Not only this, you can also use the dictionary. For example, I'm using the dictionary. For example, dictionary is equals to, dictionary is represented by a set, opening brace and closing brace. Here, assume that I'm using one, okay, just I'm using the string. This is the key and this is the value. And the two, so here key value pair, right? I'm using key value pair. Key is 1 and its value is PS raw. And 2, here I'm writing learn and code. Just I'm writing in small letters, learn and code. So how many key pairs are there? 2. So in case of dictionary, how to search? So to search a particular member in a dictionary, you have to use only the keys, not key values. By using key values, we can't search. Key values are not valid. You have to use only keys. See, if I say, for example, just I'm writing that one in dictionary, DICT. Is one is there, right? One is there. In this case, it returns true. But you can't search PS raw in dictionary. Why? Because it is only the value of the key. Okay, you have to search a member, only a key member in the dictionary. This is how the membership operator in as well as not in is going to function, right? Next, we are going to see the identity operators. Now we are going to talk about the identity operators in Python. Before moving on to identity operators, let us discuss the concept of objects. In the previous session or in the introduction classes, we said that Python is purely object-oriented programming. That means we are talking about objects. Everything is treated as an object. Already in the previous sessions, we have seen that we have the objects of type integer objects, okay, and floating point objects, and we have string objects, we have the Boolean objects. So everything, whatever the data items we are using in the Python are known as objects. And we know that objects are belongs to the class. Or we can say an object is the instance of the class, or we can say it is the instantiation of the class. For example, if you want to take a variable s1 in which we are going to store some string, assume that hello. If I write hello, s1 is equals to hello. Now hello is the object, okay, that is stored somewhere in the memory location. What is the value here? Hello, right? This is the content of the memory, and the name or the label given for this memory location is hello. I can say s1 or hello is the object, belongs to the class string. The class is string, right? Hello is one kind of string. So string is a class and hello is an object. And another important thing is whenever an object is created and stored in the memory, for each and every memory location, the system is going to provide an ID. Okay, this is very, very important. Some identification number are the some value ID value is assigned to each and every object by the system. Now, important thing here is how to get the ID. IDs are given by the system by itself, but how to obtain the ID of a particular object? To get the ID of the particular object, we use the function called ID, this ID function. Okay, by using this ID function, we can obtain the ID of an object, or we can say the value that is unique given to the memory location is obtained. Let us see one example here. Now at Python shell, here we are using x is equals to 10. Now we have created a memory, internally the memory is created for the object 10. What kind of object it is? Integer object. What is mean by this integer? Integer is the class. What is 10? 10 is the object. This is called object. What is the label that is attached to this? This is x. X is the label. Now, when we try to write the statement y is equals to 10 in this concept, do you think that there is separate memory that is stored for y like this 10? No, this is not correct in Python. See, the value here is 10 and here also 10. Okay, same value, right? When you try to store the different value 20, in this case, it is going to create a separate memory location where the object is 20 and the class also integer. This is different value, okay, and this is different value. But when we try to store the same value 10 like this, in this case, what happened? The separate memory is not allocated. Separate memory location will not be created. Only the label y, second label y is given to the same memory location 10. The memory is not wasted. Only one memory location is there. Both x and y are the labels for the value 10. In this case, when we say y equals to 10, y is not going to have separate ID. Okay, there is only one unique ID. That means whenever we say x equals to 10 and y equals to 10, only one memory location is used, but the labels are different xy. Now, in this case, if you want to get the ID of x at the at the Python shell, just you say ID of. If you say ID of x, assume that the ID for this memory location is just assume 1, 2, 3, 4, 5, 6. Just assume it's not unique. It is given by the system. Whenever you say ID of x 1, 2, 3, 4, 5, 6, it will give. Just example. Now, whenever we try to get the ID of y, same 1, 2, 3, 4, 5, 6 will be obtained. The ID is same. Okay. Now, in this case, what I'm going to use? I'm going to use the concept of identity operators. Here I'm using identity operators. There are two types of identity operators. The first one we are going to talk about is and second one is not. Is and is not. Now, in the previous example, just now I said that both x, y are pointing to the same value 10, right? And here the ID is like this. Just in this case, what happened if I apply the is operator at dollar shell, sorry, at the Python shell, if I say x is y, x is y, x is y. Now, in this case, this operator is not going to compare the value of x10 and the value of y10. No, it is going to compare the IDs of x and y. What is the ID of x? 1, 2, 3, 4, 5, 6. Y is also 1, 2, 3, 4, 5, 6. Right? Now, is going to compare IDs of x and y. How to get the IDs? By using the function ID. This is the logic. Now, if I say, for example, just now I said x is equals to 10. Now, instead of saying y equals to 10, I'm saying it is 20. In this case, what happened? We are storing different objects. When we try to store different objects, different memory locations are created for 10 as well as 20. For this 20, the label is y. For this 10, the label is x. Assume that 1, 2, 3, 4, 5, 6 is the ID of x. And next, assume that 6, 7, 8, 6 is the ID of y. In this case, both objects are different. Though the class is same, separate memory locations are there. In this case, if I say x is y, in this case, so here in the first case x is y, yes, x is y, both are same, both IDs are same. In this case, it returns true. But for the second case, when you say x equals to 10 and y equals to 20, separate memory locations are created and separate IDs are given. In this case, when you say x is y, it is going to return false. This is very, very important. Now, similarly, if you take some variable s1 is equals to hello, here I'm writing hello. Now, next I'm using s2 is equals to hi. Okay, here we are using two objects. This is hello and this is hi, right? Our strings are same? No. What is the label for this s1? What is the label s2? And each one is going to have different ID 2, 3, 4, 5, 6. Assume that these are the IDs. So in this case, whenever we try to use S1 is not S2. So S1 is not S2 means S1 here we are going to get ID. It is taking ID of S1, 2, 3, 4, 5, 6 is not S2. Here the IDs are not same. Is not. So here the result we are going to get is true. This how we are going to use the identity operators is and is not. But before going to apply is and is not, you should get the IDs by using the ID function. This is how the identity operators are going to work. So with this, we have completed identity operators, membership operators, and assignment operators. With this, I'm going to close the session. In the next class, we'll see the remaining topic. Thank you very much for watching.